Hello everyone, we're going to look at a resistivity question that I've kind of made up. So let's look at how to solve this. Okay, so if our question is, if the sun is generating 100 watts onto a tree's fruit that has a width of 0.1 meters and a thickness of 0.05 meters with two electrodes placed 8 centimeters apart, calculate the resistivity of the cellulose fruit when a current of 10 amps is measured by the electrodes. Approximate the fruit as rectangular. Okay, so this is kind of a mouthful, and it's kind of hard to see what's going on maybe. So I'd like to start off by just listing the variables that are given. So starting at the beginning, it says if the sun is generating 100 watts, so we have 100 watts, that's going to be our power, that has a width of 0.1 meters, so 0.1 meters equals width, and a thickness of 0.05 meters. 0.05 meters equals T. With two electrodes placed 8 centimeters apart, so 0.08 meters, let's just give that as a length. Calculate the resistivity. So what we're looking for is rho, our symbol for resistivity, of the fruit when a current of 10 amps is measured by the electrodes. Okay, so we have 10 amps, and that's our current. Okay, so that might be step one, just listing what's given and what we're looking for. Maybe also it would be good to draw a picture. So this may not be the best picture, but let's say we have something that looks like this, right? So this is our thickness. This right here is our width, and we have two electrodes separated with a current going through them. So this is kind of what I think of when I've read through this, what actually we're thinking about. So after listing what we have, what we need to find, and drawing a little bit of a picture, let's start listing equations that could probably help us solve for rho. So I would start with the equation R equals rho times length over area. Okay, so we have rho in this equation, so we can rearrange this to find rho. So resistivity equals resistance times area divided by length. Okay, so we could use this equation to solve for resistivity. And I think we could calculate the area through width times thickness. And this might seem not exactly intuitive, but in a more ideal example of like a wire, right? The area right here is the area we would use in this equation. So it kind of does make sense if we have this piece of fruit that this area, which is the width times the thickness, kind of corresponds to this area of a wire. So that does make sense. And we have a length. I'd say that is the length between the two electrodes. So 0.08 meters. And the only thing we need is R. So we don't have R anywhere within this question, but maybe there's more equations that can help us. So throughout this unit, we've been looking at Ohm's law, and this brings I, current, into the equation, but we still don't have voltage. But the problem starts off with power. And if we look at our equation sheet, we see that power equals current times voltage. So we could combine these two equations by plugging IR into V, because we don't have V, to give us power equals current squared times R. Okay, so now we have power, which is our 100 watts. We have current, which was our 10 amps. And we don't have R, but we can rearrange this equation to give us R. So R equals power divided by I squared. Okay? Now that we've figured this out, we have both of these variables. We can plug it back in to our equation for resistivity, which is ultimately what we're looking for. So after, rearranging all these equations, let's rewrite what rho should equal. Rho equals R, which is P power divided by I squared times the area divided by the length. So now we can just plug in our list of what we did know over here into our equation for resistivity. So resistivity equals 100 watts divided by 10 amps squared times our area, which is width times thickness. So 0.1 meters times 0.1 meters times 0.05 meters divided by our length. So the length between the two electrodes, which was 0.08 meters. So we find that our resistivity equals 0.0625 ohm by meters, or 6.25 times 10 to the negative second ohm by meters. So this is our answer for resistivity. Thank you all for watching.